Hello guys, welcome back to Infinite Insight Geometry, lesson 2.6, vertical angles. Alright, let's begin. So, before we talk about vertical angles, we need to learn about the main mechanic in this topic, which is intersecting lines. They are lines that intersect at one point. Now, these lines are not parallel because, as you can see, they do intersect and parallel lines do not intersect. But intersecting lines do intersect, and they only intersect at one point, and that point is called the point of intersection. The key thing here to notice is that when two lines intersect, they make four angles because they make four rays, the point of intersection and the four rays coming out of it. And those four rays make four angles, and they all are adjacent angles to each other. And the point of intersection is the vertex for all four angles. As you can see in the diagram, we have the point of intersection, and then there are four angles, one on top, one to the right, one below, and one to the left. Vertical angles are a pair of opposite angles for when two lines intersect, and a linear pair is a pair of adjacent angles for when two lines intersect. So when you have when two lines intersect, you have four angles, and for one angle there will be two angles on each side, one on its left and one on its right, and then the angle opposite from it. So you have one angle, you have its opposite, and then you have two other angles adjacent to it. As you can see on these diagrams, angle 1 and angle 2 would be a vertical angle pair, while angles 3 and angle 4 would be a linear pair. Those are the definitions for 2.6. You just have intersecting lines and the point of intersection, as well as the vertical angle pair and the linear pair. Now, the two theorems that we are going to learn are the vertical angle theorem and the linear pair theorem, and we have to prove both of them before we can use them in theorems and proofs. So the first one we're going to do is not the vertical angles, but instead the linear pair theorem. For the linear pair theorem, we had to prove that angle 3 and angle 4, which is a linear pair, we had to prove that all linear pairs are supplementary. Pause now. Please pause now and think. What kind of patterns can you make? Try to make a two-column proof. Explain your reasoning with the statements and the reasons. And here is the two-column proof for the linear pair theorem. Now, the linear pair theorem, it can be easily deduced that angle 3 and angle 4 are adjacent, and their non-common sides form a line, because that's what a line is. They just form a line, and then the line that intersects through it forms adjacent angles where the non-common sides form a line. Meaning that angle 3 plus angle 4 should be a straight angle, meaning that their measures must add up to 180 degrees by the angle addition postulate and the definition of a straight angle. Therefore, angle 3 and angle 4, since they add up to 180, must be supplementary to each other, because that's a different definition of supplementary. Now, vertical angles are a little different. As you can see here, here's the linear pair theorem. If angle A and angle B make a linear pair, then angle A and angle B are supplementary. But now that we've learned the linear pair theorem, we can use this to prove the vertical angles theorem, because we have already defined the shortcut. So now we can use the shortcut, and one of the ways that we'll use the shortcut is in the vertical angles theorem. Prove that angle 1 and angle 2 are congruent. I'll give you a moment, pause now. And here is the entire two-column proof for the vertical angles theorem. We have angle 1 and angle 2 are vertical angles. That's a given. You can also see that angle 1, angle 3, and angle 2 and angle 3 are both linear pairs, because that's the definition of a linear pair. We can see that angle 1 and angle 3 form a straight line, as with angle 2 and angle 3. We can also see that angle 1 and angle 2 add up to 180 degrees, as well as the measures of angle 3 and angle 2. Therefore, we can move angle 2 to the other side, so we have both angle 1 and angle 2 are both equal to the same thing by the subtraction property of equality, meaning that we can substitute and define angle 1 and angle 2 congruent by the definition of congruency. So, we have just proved the vertical angles theorem with the linear pair theorem. If angle A and angle B are vertical angles, then angle A and angle B should be congruent. And that'll be all for today's lesson. If you liked the video, please like and subscribe. I have my email down below in the description if you have any questions, and I will see you all next time.